In my last video, I used old Power Tool 18650 cells to build this custom battery pack to be used as a starting battery for this, my mini bulldozer. And I tested it out just using a little adapter cable plugged into an old wiring harness, but this lead acid battery is all done. I want to get it out of here, find a place where I can mount this new battery, and I think I found one. So underneath this seat has this big cavity with nothing in it, and there's some space between the bottom of this and these big old dangerous looking wheels down below. So definitely want to be respectful of that and give it lots of clearance, but there is lots of space right here. And I think that the place that the battery can go is just between these two existing bolts that hold down the seat. So if I mount it there, when it flips over, it'll be sitting up here well above the wheels, and the end of the cable will be close to where I already have a fuse block, and I can make the junction right there. I think it'll be nice and clean and also open up the space outside for something else. So in this video, I'm going to figure out how to make a mount to hold that battery underneath the seat and attend to some other upgrades that I want to make at the same time. It's getting windy, but I was able to remove the battery and the mount from the tractor. Here's that mount. It's got kind of a universal adapter that I built a few years ago on top. This is all the connectors I typically use, from an Anderson SB175 to an XT90 to an SAE style connector. This is what's on like battery charger maintainers, out to some ring terminals. So I can definitely use that somewhere else, if not still on this project. I don't need this mount anymore, and I definitely don't need this battery anymore. Wow, it's from 921. It only made it a few years. Not even. Meanwhile, back over on the tractor, I removed the fuse box cover. It's got a mega 125 amp fuse inside, which is more than enough for what this engine will ever need to start, or its linear actuator to operate the blade. So it'll make it really easy to wire in, because I just need to pull a lead off the output of the fuse over to a new EC8 connector where the battery is going to be. Negative's going to be even easier. I think I'll just snip this existing negative cable, flip it around so that its ring terminal goes into this hole, make a new grounding point, and then the cut end I will terminate into EC8 up again where the battery's going to be. And as long as I can get all of this to fold down into the open space when I close the seat lid, this is going to work out pretty easily. All right, we'll see how much of this I can do without getting my big straw hat in the way. I've trimmed off the negative at the point where it has enough space to go up to the new grounding point. So I'm going to pull it through, and I'll be able to use a 5/16 hole for number 6 cable on the new grounding point. So I'm going to trim this back, and we will install the lug. Compared to the straight cutters, these strip a lot easier. This is relatively straightforward. If you've got the space to twist the cable in your hand. There we go. All right, and then we'll slip over some heat shrink tubing. Finally, the fitting. And I'm going to orient it so that it's flat with the side. And these are my crimpers. They're a HX50BI, and they'll do number 8 through single aught cable. So I'm going to try to crimp in this direction without the terminal falling off. Yeah, let's go for it. Okay, heat shrink is on, so now I should be able to run it back through this grommet with the terminal just fitting through, and then loop it up around, and it lines up pretty nicely with the new grounding point. Okay, I've attached the original ground to the new ground point and mocked up some cables here to where they may be able to interface with the new battery, but I won't know until the battery's actually in place. And I think I can use these two existing bolts here, which are for the seat frame, and build some sort of mount that goes between them that holds the battery right in between, ideally with the cable dropping down to this corner where it can meet with these existing cables. I just have to work on getting these cables to fall down and out of the way when the seat tips down without getting pinched and without getting into the works here. So next step is building that mount. I started with this PVC perforated sheet that I cannot remember where I got it, but I used it for, I think, draining things after I put them through the ultrasonic at one point. Anyways, it's just a PVC sheet that has a bunch of holes in it, and I ended up laying it out and making it into kind of a big cross shape with my Sawzall. And then with the heat gun, I was able to heat the outside sections of the cross and fold them up into what started to become the cage that would be fit around the battery pack. I had to experiment with different ways of making the 90-degree corners, and also had to learn that, you know, the material gets consumed as you make a curve, but maybe you underestimated or overestimated. You can't just trace around the object directly. It's going to need a little bit of adjustment after that. But I started to get the hang of it, and finally also decided I didn't need the entire battery pack to be completely wrapped, and so I cut out some reliefs that allowed the cables to route more naturally, and it also let me do some custom contouring around the raised section of the battery pack where there were the heavy battery leads running underneath the shrink wrap. So more sawzalling, more bending and rebending and tweaking and shaping. I finally got a product that I really liked, and it fit the battery really well. I made these wings that extend down the side of the battery to retain it left to right. And then the same material that goes over the top and the bottom of the battery, I made into kind of a Z shape. So it folds down over the top or the bottom and then flips out to be flat against, in this case, the bench. And that will be the mounting surface when it's flipped upside down. And getting those nice and square and flat took a little longer, but it was definitely worth it in the end. I'm really happy with how this battery mount came out. Working with this PVC material was pretty fun, and it allowed me to do things like this. I was able to create this raised hump here to clear the main battery leads, and that would have been difficult with, say, aluminum or some of the material I might have used. In this case, I just heated it up and I was able to contour it to the actual battery shape. So it fits nice and snug. I made these winglets on either side, which will locate the battery side to side. And then for the main mounting flanges on either side, I just measured the distance between the two bolts on the Mini Dozer, and then literally clamped these together, and when it was upside down, measured the same distance, drilled some holes, and I bent things such that when this is actually installed, of course it'll be sitting like this, but on my desk for demonstration purposes, when it's actually installed, I made the bend so that this will actually be putting some force down on the battery, just snugging it down. And so I think it's totally going to be adequate for the load it needs to carry. It allows a little bit of cooling even. Always fun to try out new things with new materials. And here's the mount as installed. It's working exactly how I had hoped. It's actually really easy to install because these bolts are retained by the seat rail on the other side. So it's a one-sided installation, nice little bonus. But yeah, battery's sitting in a good spot. It's really secure, and the cable is hanging down to a place where it's going to be easy to interface with the other cables that are already on the chassis. And just to see the clearance, you can look behind here. Yeah, it fits up there really nicely, and plenty of space to make the electrical connection too. Here's where I'm at. I was able to reuse the cables that were already here, formerly going out the side for the lead acid battery, flipping, cutting, soldering, adding terminals. Now they go from the new ground point and from the, I guess it'd be the input of the fuse block up to an EC8 connector and onto the battery underneath the seat. So that's working well, and what I'm really excited about is that all I'm gonna have to do is zip tie these here. I'll show you later how well the cables just fall into place and are kept away from these wheels when I put the seat down. So next step, I'd like to reincorporate this thing. This is my SB175 Anderson connector, and I use this for jumping this thing from a vehicle or charging or jumping like a riding lawnmower from here or back and forth. Although with these new lithium batteries, hopefully that becomes a thing of the past, but I still want to reinstall this, and that's where these two holes come into play. I figured out how I can stick this down there. This also gets me other connectors I use, like this maintenance charge connector. So let me show you how that's going to work. Well, I'm losing my light, but I'm happy to say the electrical is all done, and it worked out just how I was hoping, actually better. So underneath the fuse block, we have the battery power in on this side, and then battery power out on the other side to the chassis, and then also to this Anderson SB175 right next to it. Next, we have the negative on the new ground, which goes to from the chassis to the battery, and then from the chassis onward through this cable up actually to the base of the engine mount. And similarly, there's a ground from here to the Anderson plug as well. I was able to put a longer stud in one of the mounting holes so that I could put this add-on clip, which then just lets me just create a little zip tie loop that holds these extra charge cables as well. Really simple and effective on that. Big question is, does it close? And it really does nicely. That's what it looks like when it's all done. Everything out of the way, everything accessible and functional. In my build video, I showed how a deep discharge of the overall battery pack would lead the individual cell group voltages to diverge, and that's exactly what I'm seeing here. After a day that involved a lot of cranking the engine, not a lot of driving around to charge things back up, the overall pack voltage is down to 12.15. Moreover, the variance between the top and bottom cell group voltages is 0.631 volts, so that's pretty significant. Now, I also showed that if I charge this all the way back up, those cell group voltages will actually reconverge nicely. But in this case, I'm relying on the alternator from the engine, which was designed to charge a 12-volt lead acid battery. So on its best day at operating RPM, it's going to do like 14.4 volts. And that may not be enough to get those cells to reconverge. So I'm going to try something else. This is called a flying capacitor balancer, or it's called a battery equalizer or an active balancer. Basically, it's a whole bunch of capacitors and MOSFETs and some control circuitry. And what it does is just steal from the rich and give to the poor. It takes power from the cell group with the highest voltage and transfers that over to the cell group with the lowest voltage. A very simple algorithm. And these can be very efficient and transfer a lot more energy than can a typical BMS with their resistors, which basically don't even transfer energy. They just hold back the cell group with the highest voltage while you're doing a charging operation. This does draw some energy, but my understanding is that once the balance is done and there's no real transfers happening, this consumes very little, if any, energy. Unfortunately, I didn't look closely enough, and the connector on there is not the same as my balance lead. And so I'm going to have to make some sort of adapter. Fortunately, the balancer did come with this nice little wiring harness, and it also came with an acrylic base kind of shell that I can install it into with some standoffs and some screws. And so I think what I'm going to do is start by making an adapter cable. I do have one of these JST 0.1 inch sockets that matches my balance lead. So I think that it'll be pretty easy just to make an adapter from this humongous connector to the typical one that's on batteries. Then I can test it out, see how well it's actually transferring energy, and decide if I want to permanently install this. It's advertised as being able to transfer up to 5 amps, which seems hard to believe, and actually I kind of hope it's a little bit less than that. But the wires that are on here could handle that for a short amount of time, and that would only be under drastic circumstances where we had very wide cell voltages. As I understand it, as the voltages get closer and closer, the current transfer gets smaller and smaller. So these are things that I can test once I have an adapter cable made up. You've seen me do plenty of soldering, so I'm going to do the standard YouTube trick where I go like this, and it's done. I've got the balance cable made up. I also added one of these kind of grippers onto the battery side connector, so I'm not pulling on the cables all the time. In any case, I can hook everything up through this balance connector for my Tenergy charger. We'll start by connecting up the balancer to its own leads, and then we're going to plug the other end of my adapter into this temporary little cable, which is 4S on this end and 5S on the other end, which will be available on the Tenergy balance board. All right, and now the 5S from the battery, 4S from the battery plugs also into that board. I'm losing track of my S's here. Everything's in parallel. So now we can plug the board into the display for the cell balance, and theoretically we should be balancing. So let me take some measurements with my small amperage DC clamp meter. I did a video on this one a little while ago where I sort of calibrated it by opening it up and finding the pots that set the 0 point. But being DC, it's much better if you just use it in delta mode. So I always start with the 0 right next to where I'm going to work. So it looks like probably cell group 3 is probably getting the most energy transferred to it. It's the lowest. So if we start with the ground, there's 1, 2, 3, and I think positive then would be this direction on number 3. What do we observe? Wow, 0.77 amps. That's pretty significant. So yeah, the overall voltage of the pack, 12.18, that isn't changing much, but if you look at the variance between top and bottom, it's counting down. It was at 274, now 273, 21, 270, and 0.7 amps. That's actually pretty significant and right around the range that I'd like to see here. I didn't want to see a full 5 amps. That would be a little bit much over time for these balance wires, but I also didn't want to rate down in the tens of milliamps like a lot of the BMSs offer. So that's the positive to cell group 3. Let's see what's happening to the highest cell group, which is cell group 1. Do we see current the other way? We do. I don't know if I have this forward or backward, but it had minus 0.77 going to cell group 3. And now on the highest cell group, we have positive 0.813. So that would tell me that power is changing directions from 1 to 3. Pretty cool. It's been about 45 minutes and the total variance is down to 24 millivolts. And let's check the flows of energy between the different cell groups. Let's go to cell group 1. This is one of the higher voltage ones, so it's actually giving off energy. And if you think of in terms of conventional, electrical theory, I guess, it's positive to negative. So when you see a positive value here, that means that cell group 1 is giving off electricity. And so then we'll go, that's 96 milliamps. Let's go to cell group 3, which is the lowest, and it's receiving 80 of those milliamps at least. So the negative would mean that it's coming into the positive side of the battery, or it's charging. So that's why you see a negative. At least that's the way that I've been thinking about it, and it makes sense to me. The last, let's see, cell group 4, kind of in the middle, kind of not doing a lot. Same with cell group 2. We don't expect to see a ton here either. So yeah, this is working as expected. One more thing, I want to see what the heat is like on these capacitors. Okay, there's not really much there. I thought I would just see if they're all lit up, but maybe when they're at full chooch doing 5 amps, you see some more heat here, but nothing really to speak of at these low rates. I did notice that there is a light on the back that shows you when it's running. And furthermore, there is this solder blob on the front that says run. Let me zoom in on that. As I understand it, these are actually 2 contacts that by default are just blobbed together. I'm going to install one of these mini switches so that I can flip it on and off. So strangely, the light is on all the time. So when I flip the switch though, that's when I did see these voltages actually pretty quickly start changing. Let's unplug it. Oh, I think it just has a lot of capacitance and so it stays on. That's probably all it is. So we're off. Let's plug it in while it's off. Yeah, okay, so we're not seeing anything yet because it's off. Flip it to the on position. There we get a light. So I bet if I left this off, it would eventually turn the light off as well. So that's going to be a nice little easy modification for being able to operate this thing. I could also wire in a remote switch, of course, and just flip it on and off when I want balancing to happen, versus if I'm going to leave a battery plugged in but not used for a long time, I could flip that off so that there's even less draw. Got to be careful about setting this down on something metal. I better get that acrylic base installed quickly. Okay, I left this balancing overnight. Let's see where it's at. 7.6 millivolts. Wow, very low. And now down to 5 it's showing too. That actually makes a lot of sense because I think the cutoff for this balancer is 5 millivolts and then it goes to a deep sleep. And then at some point, I don't know what the level is where it kicks back on, but it will start balancing again back down to 5. So let's see if we can measure any current going through any of these wires. We probably won't see anything because we would only be measuring the power that the balancer is consuming. And it's supposed to be like microamps, so I don't think I'd even really be able to measure that. But we're showing 17 milliamps there. Tough to know at those low levels if it's just the accuracy of the clamp meter, because honestly, it's not really able to get down that low. But basically, no energy going in and out as far as I can tell from the battery pack. At least not on these positive lines. We'll come back and revisit the negative after I measure all the positive lines. It is getting pretty darn close to 0 on a lot of these. Okay, so just very little quantity of any energy transfer. If I go to the negative, which is technically backwards right now, it's down at 18, so very, very low, and I'm going to say essentially 0. I don't think I actually have the right equipment to measure how much this is consuming, and it's a little unclear how I would measure that anyways, because obviously it's going to be pulling from the battery, but does it pull from just a single cell group? Is it using the whole battery? I don't really know. So I would need to rig up a little shunt or possibly one of those Adafruit INA 219 modules. That could probably measure really low currents on this, but I'm not going to worry about it past here. I'm pretty happy with 5, now 4 millivolts variance. It's doing its job. Mounting the active balancer is going to be pretty easy, but it did take a kind of strange looking modification, and that lets it use an existing hole on the seat platform. Pops through in an area that's exposed when the seat's all the way forward, and just a washer and a lock nut. Well, I'm happy to say the installation is complete, albeit with a couple changes. I added this angle aluminum top and bottom to spread out the load on the plastic. And even though I'm using a flange nut and I considered using a fender washer, either way there would still be a point right at the bottom of them where all the stress would transfer through the plastic. So I didn't want to have any fatiguing or cracking, and this was an easy, cheap insurance to help out that plastic. And the wiring's all done to the active balancer. This is going to work for now. It's starting to hit me that I can't just pressure wash with abandon like I've gotten used to. The battery could take it, but obviously this exposed circuit board, it was not really meant for this situation. I may put it in a little waterproof box long term. We'll see what happens with that, but for now it'll work just fine. And she's starting up great. And she's starting up great. There we go. Of course, when I'm on the camera. Well, we can blame the engine, not the battery. It's cranking great. Well, the engine not starting is actually a perfect reason to show off that this thing does not need the engine running to run the blade. And the extra current from this heavy-duty battery is really making this shine. It used to only go up and down with any sort of force with the engine running, but now it's got it all day long. It's going to make it nice to operate. It's got a pretty heavy-duty linear actuator over here, rated for 500 pounds, and it sucks down something like 30 amps I measured one time, so it needs the power. Just one more thing, I've painted this area of the fender where the old battery mount came off, and I'll show you why. This is the last thing that it needed. Where I used to have a lead acid battery, now I've got storage for tools and all the stuff I inevitably end up picking up off the ground. Things that end up in my pockets now can end up here. It's also accessible when I'm sitting on the seat, which, speaking of, I can flop that seat over again. It locks down. Battery and everything fits nicely up inside, and of course I've got my power plug selection here on the back. That's actually never been more convenient, so I'm really happy with how all this turned out. This is actually something that I use for certain types of work, and let me tell you, it just makes me smile as well. I'm eventually going to paint it, and at that point I've got a new seat that'll go on here as well, but for now I've got a cover on the way. But it turns out I actually have some work I want to get done with this thing. If you're still here, I hope you enjoyed this video. It's not a D10 will it start, but if I can find one of those on Craigslist, I'll build a battery for it too. If you found this useful or entertaining, let YouTube know by clicking the like button. Feel free to ask questions in the comments, whether about Magnatrac or a battery pack. But most of all, thanks for watching.